What's up, you guys? In this one, we're going to be going over the quadratic formula. As you can see, you guys should have seen this in Algebra 1. There should be nothing really big that you're learning in this one other than something called imaginary numbers, which are pretty cool. I like them. This is when the quadratic is in standard form. So remember that standard form is ax squared plus bx x plus c, and it needs to be equal to 0. So these go straight with it. So the b is the number in front of the x, b squared, so the number in front of the x squared minus 4ac, so a and c, all divided by 2a. That is our quadratic formula. All this does is it allows us to see our solutions or our x-intercepts just like solving does. So this is just another way to solve quadratic functions. All right, so really, we're going to jump into it. So again, make sure you are in standard form. So with this one, we need to move over that 19. So subtract 19 from both sides such that it's equal to 0. So x squared minus 13x plus 2 equals 0. And then you can use your quadratic formula from there. So I have x equals negative b. Here I'll write it over to the side, negative b plus or minus square root b squared minus 4ac all divided by 2a. All right, so I'm just going to be plugging numbers into that. So if I have, here is a is 1, b is negative 13, take the whole number, c is positive 2. So going through this, x equals negative 13, because b is negative, so I'm substituting negative 13, plus or minus the square root of b squared is 169 minus 4 times a times c, all of that divided by 2 times a. So then it's just a matter of simplifying the numbers from there. There's really not too much to this. So I should have x equals 13 plus or minus the square root of, let's see, 169 minus 4 times 2 is 8, so 161, all divided by 2. The other way they could write this is they could split this up into two fractions, because I have 13 divided by 2 plus or minus the square root of 161 divided by 2. They could write that one of both ways. I prefer it the first way so it looks a little bit neater, but I think Apex actually prefers it the second way. So just know that all that they're doing is dividing 13 over 2 and root 161 divided by 2. That's it. That's all they're doing. All right, so part B here, another quadratic formula one. So notice we have 12 over here, so minus 12, minus 12. We have 3x, so plus 3x. Make sure you do the opposite thing. So we have 4x squared minus 12x minus 28 equals 0. So this will be a big number, but notice you can divide everything by 4 first. Save yourself some time. Go ahead and divide all of these things by 4 because they're all divisible by 4. We're really dividing both sides by 4. So now this becomes x squared minus 3x minus 7 equals 0, such that now our numbers are smaller. We'll still get the same solutions, but we have less numbers to work with in our quadratic formula. Save yourself some time. So again, a is 1, b is negative 3, take the whole thing, and c is negative 7. So we have x equals negative 3 plus or minus square root b squared, which is 9, minus 4 times 1 times negative 7, all divided by 2 times a, which is 1. So this becomes 3 plus or minus, so let's see, this is 9 plus 28, so the square root of 37, all divided by 2. And again, they can switch that up and say 3 over 2 plus or minus the square root of 37 divided by 2. They can make those two different fractions. All right, with part C here, same idea again. I'm actually going to skip D. There's no point. You guys are catching on, I'm pretty sure. Again, you guys saw this in Algebra 1, so there's nothing that big of a difference. All right, but make sure you guys equal it to 0, so plus 5 minus 3x minus 3x. So I have negative 2x squared plus 2x plus 17 equals 0. That makes 0, that makes 0. So now, from this point, this 17 is prime, so nothing will divide out. I can't divide everything by 2. It's just going to make my situation a little bit more convoluted. So with this, I would make that A, make this B, make this C. Right? So going through this, I don't want to sneeze, but I have to sneeze. Don't do it. Don't do it. It's wrong. So x equals negative 2 plus or minus the square root of b squared, which would be 4 minus 4 times a, which is negative 2, times c, which is 17, all divided by 2 times a, which is negative 2. So then just simplify those numbers. So I have negative 2 plus or minus. Let's see, this is 4 times 2 is 8. 8 times 17 is 80 plus 56, so 136, so 140. So square root of 140, that should reduce, we'll think about that, all divided by negative 4. So now with this square root of 140, let's see, 4 goes into it. 4 comes out with 35, and 35 is 7 and 5, so it's, yeah, that's it. So the square root of 140 is square root 4 times square root 35. All right, if you're not as fast as that, feel free to use a calculator. Check yourself. So what this becomes is negative 2 plus or minus 2 root 35, square root of 4 is 2, all divided by negative 4. Now notice, all the numbers on the outside are divisible by 2. So what I can do to this now, and I'll go ahead and split it up into the different fractions like you'll see in Apex. Negative 2 divided by negative 4 is 1/2, plus or minus 2 divided by 4 is 1/2. So root 35 divided by 2. So that's like saying 1 root 35 divided by 2. This is how you'll probably see your answer in Apex. That's all it is. All right, moving on. With E, I'm just going to show you this one real fast. We already have it set up, so I'm just going to throw this stuff in. It's a negative b plus or minus square root of b squared, so 36 minus 4 times a times c, all divided by 2 times a, which is 1. I'm sorry. So now, notice in here, this is 36 minus 4 times 9, which is 36. So I have negative 6 plus or minus square root of 0, essentially, all divided by 2. Square root of 0 is just 0. So I have plus or minus 0, so that just goes away. So really, the only thing I have is negative 6 divided by 2, which comes out as just one solution of negative 3. That's it. You just have one solution. So sometimes you can have one solution. Next thing we're going to talk about is when you have negative solutions. So there's something in math called complex numbers, kind of like these exist because we have to come up with things that like model real life. As mathematicians, this is what math is. It describes real life. So the way I like to put it is there's air all around me. I'm hitting tons and like millions and thousands of air molecules. There's not like gnats in here as far as I know. There might be, but like there's air all around me. It's imaginary. I can't see it, but it's something that we as humans made up. We know it's there. I mean, we've proved that it's there. You can condense it in pressures and things like that. But it's something that we cannot physically like see with the naked eye. We can't just be like, oh, there's an air molecule floating right in front of my face. I can't see. There's air in the way, right? So imaginary numbers are kind of the way that mathematicians, if we need to, we think about forces that aren't necessarily perceivable, but they are still affecting the way that our equation works. So imaginary numbers happen when you're taking the square root of a negative number. So yeah, I just said that. They are written in the form a plus or minus bi. Something else cool to note that is if we have 2 plus 3i as a solution, we will also have 2 minus 3i as a solution. That's just because of this, the plus or minus in our quadratic formula. This right there, when we come up with the imaginaries, we have the positive and the negative of that solution. So that's why that they're called conjugate pairs. I think we'll see more of this later in the section. But for example, like we know the square root of the square root of 49 is plus or minus 7 if we take the square root. Now if we take the square root of negative 49, it actually creates the imaginary numbers. What this is it's the square root of 49 times the square root of negative 1. This square root of negative 1 is how we represent the imaginary number. It's called I. So the imaginary number I is represented with the square root of negative 1. That's how we show that we are taking a negative square root. We have an imaginary solution or an imaginary number. They're also called complex numbers. All right, so with these, It's not too difficult to solve for them. It's just whenever you see a negative square root, you got to know that you're taking an imaginary solution. Here, doing the same sort of thing. A is 1, B is 15, C is 12. So I have x equals negative b plus or minus the square root of b squared, which is 225, minus 4 times a times c. So 4 times 1 is 4, times 12 is 48. All divided by 2a. 2 times 1. Right? Well, I messed up. Sorry. I was trying to make one with imaginary solutions. This one actually doesn't have them. So we're just going to skip it for now. That's just more of the quadratic formula. All right, so here, notice it doesn't equal 0, so I need to make it equal to 0. So minus the 3x and plus the 31. So minus 3x plus 31. So I have 3x squared minus 8x plus 15 equals 0. So with this one, I have A, B, and C set up for me. So I have x equals, come on pen, negative b, so this is 8, plus or minus the square root of b squared, so 64, minus 4 times a times c, so that is 4 times 3 times 15, so 180, so 64 minus 180, all divided by 2 times a, which is 3 in this case. So now, I have 8 plus or minus the square root of negative 116, all divided by 6. So now that square root 116, that can break down. So what is that? 58 and 2, and then 29 and 2. So it should be square root 116 is square root 4 times square root 29. So now notice also that this negative here, that's going to create an imaginary solution. So what this does for us is we can write this as 8 over 6 reduces to 4 over 3 plus or minus 2, because this is 2 root 29, instead of the 116. 2 over 6 reduces to 1 over 3, so I have root 29 I over 3. That I just represents the imaginary number. Anytime that you have a square root of a negative number, it comes out imaginary. That's really all there is to it. Instead of rewriting the negative, we just pull out the negative and we put an I on the outside to show that it is imaginary. All right, last one here. So here I could actually do completing the square with it, but we won't worry about that. We'll do the quadratic formula still. So it's a little bit ugly, but it's still not a big deal. So I have x equals negative b, so in this case it would be just 5, plus or minus the square root of b squared, so 25, minus 4 times a times c, all divided by 2 times a. Well, dang. Because 4 times 1 times 25 over 4 is just going to come out 25. So 25 minus 25 is 0. So this solution will just come out 5 over 2. There's only going to be one solution. It's not imaginary because you're not taking the square root of a negative number. All right, the last thing we're going to be talking about, I believe, almost last thing. God, this is a long video. I'm sorry. I think there's like 3 or 4 sections that this is covering. So the discriminant is the thing. Notice we've seen this before. It's b squared minus 4ac. Where have we seen that? Well, that's inside our quadratic formula. That is this part right here. So all that this does, the discriminant, is it tells us how many and what type of solutions that we will have. Notice when we had a number, a positive number, we had the positive of that number. We also had the negative of that number. So remember, this would be, let me get a different color. This 13 over 2 here, I can rewrite this as 13 over 2 plus root 161 over 2, or 13 over 2 minus root 161 over 2. So there are 2 distinct solutions there. It's that 13 halves plus this number, and 13/2 minus this number. So there's two solutions whenever we had a positive number inside of there. If we had a 0 inside of there, so notice if it was equal to 0, I only came out with one solution, like I did here, also like I did down here in the last one that we just did. If it came out negative inside there, right, we did a negative right there, notice we had an imaginary solution. And there were two of them. There's always two imaginaries if you have any imaginaries at all. There's at least two of them. So that's all the discriminant is used for. So all they're going to have us do is determine the type of solutions and how many there are. So if I take that discriminant equals b squared minus 4ac, I'm just copying the formula, again, needs to be equal to 0. If it's not equal to 0, we're going to have some issues. This is still a, this is still b, this is still c. So if I do b squared, that will be 9 minus 4 times 1 times negative 12. So this would be 9 plus 48, which equals 57. The discriminant is positive, so I will have two real solutions. I call them real solutions because they're not imaginary. Imagine that. I tried. I'm sorry. All right. Again, make sure it equals to 0. So I need to add this 3 to the other side, such that I have 5x squared minus 3x plus 17 equals 0. And then I can do the discriminant. So the discriminant is b squared, so 9 minus 4 times 5 times 17. So this is going to be way negative. So 9 times this would be negative 20. So negative 340, so minus 340. So my discriminant would be negative 331, which means I have two imaginary solutions. Remember, if you have one imaginary, you have two. You really have two. You got the plus and you got the minus. So now, in this last one, you can probably guess, and hopefully I didn't mess it up, that we'll have just one solution. I want to show you how that works. Minus 10, so I have 4x squared minus 4x plus 1 equals 0. I think I got it. So the discriminant would be b squared, so 16 minus 4 times 1, which would be 16 minus 16, which would be 0. So the discriminant is exactly 0. So that means I only have one solution for this. So one real solution. Oh yeah. All right. Last thing we're going to be talking about in this video is talking about solutions to quadratic inequalities. We're only going to do 3 of these examples, so they're usually pretty fast. First step, determine the solutions. Second step, graph your parabola. Third step, determine what the solution set is. All right, so if I were to try to factor this, looks like I can't, so perfect. But I can use the quadratic formula to determine my solutions. So I have x equals negative 1 plus or minus b squared, so 1 minus 4ac, so 4 times 1 times c, which is negative 4, all over 2 times a, which is 1. So I have negative 1 plus or minus square root of, that would come out 17, all divided by 2. So what I'm going to do in my calculator is I'm going to do the two solutions. I'm going to come out with the 2 decimal solutions so that I can figure out kind of things that I need to determine where it's going. So I have negative 1 plus root 17. I didn't get the plus in there. I'm going to insert that plus, and then I'm going to divide that number by 2. So that's my first solution, 1.56. So one solution is 1.56. The other would be if I took that square root and I subtracted it, so negative 1 minus root 17, and divided it by 2, so 2.56 negative. So x equals negative 2.56. So those are my 2 solutions for this. So now when I determine the solutions, there can be lots of things because it just wants to know where my graph or my inequality, my quadratic, is going above 0. So if I think about the graph and I have 1.56 as one of my x-intercepts, I also have negative 2.56 as another x-intercept. The other thing that I look at is whether or not my x squared is positive or not. Just like we were doing in the last video, if this x squared is positive, that means it's going to open up. And if it opens up, the vertex should be right in the middle of our x-intercepts right there. But it is close. So for this thing, this quadratic to be greater than 0, it's greater than 0 from this part and this part. So for my solution set, I would do negative infinity, right, because it's coming in from this way, going all the way up until that point. Notice it's not included, it's just greater than. So I need to go to negative 2.56, and then I need to include from this point on, because that is where it is also above the y-axis, or the x-axis, I'm sorry. So from 1.56 to infinity. Right? That would be my solution set in interval notation. They could also have x is less than negative 2.56 or x is greater than 1.56. Those are both right. I prefer to see in interval notation now. All right, so with this next one, again, you look to see if we can factor it. We can't. But we have the quadratic formula. So we have x equals negative b, so negative 5. Plus or minus square root, b squared, so 25, minus 4 times a times c, so 4 times 3 is 12, times 1 is minus 12, all divided by 2 times a, which is 1. So I have for my solutions, negative 5, plus or minus square root 13, all divided by 2. Let me go ahead and type this in real quick to my calculator and get the solution. So here are my two rounded solutions for this. So I have also an x squared, so it's positive, so I know it's going to open up. So for my graph, I have negative 4.3, so it's over there. I have negative 0.7, that's what it rounded to. I know it's going up because the x squared is positive. And again, the vertex should have an x value of it right in the middle. If they ask you about the axis of symmetry as well, the axis of symmetry is just on the line that we could fold our parabola in half and have it match onto itself. All right, so then for the solution set, notice I'm just greater than, so greater than 0 would be this part and this part, so I have again negative infinity to this negative 4.30, and then from negative 0.70 to infinity. I have both of those kind of parts of my graph that are above 0 on the y-axis. Another thing they could ask you about is test points. I don't necessarily think you need to use them, but if you were to test, say like somewhere in between these numbers, say I chose x equals negative 2. If I were to take this negative 2 and plug it into my function, it would not be greater than 0. You would see that it's actually less than 0, somewhere down there. If you were to test x equals negative 5, you would see that it is above 0, so negative 5 would be a solution. It's going to come out greater than 0 if you put it into your function. So 25 minus 25 plus 3, 3 is greater than 0, so it is greater than 0. If you were to test something outside of this, like x equals 0, so if I put in 0 for the x's, that's 0 squared plus 5 times 0 plus 3, which will also come out 3, is greater than 0. So those two parts are where our solutions exist. All right, last one, I promise. Thank you guys for sticking through this video. If you want to take breaks through it and take the quizzes individually, you are more than welcome to, because I'm pretty sure this covers multiple quizzes. All right, so here, again, our thing is factor it if we can. So I think about 12, I have 2 and 6. Yeah, I can factor it. Oh, thank goodness. So if I do x minus 6 and x plus 2 less than or equal to 0, right, then I can tell my solutions are 6 and negative 2. So with my graph then, I have 6, which is over there. I have negative 2, which is over there. And I would have a positive x squared. So my graph is going to be opening up, something like that. So the vertex is in the middle of those. The axisymmetry is also in the middle of those. So my solution, now notice it says all this junk is less than or equal to 0. So I want the parts of this that are less than, are below the x-axis, are below the ground, that are below kind of level. Level would be 0. So I have everything only from -2 to 6 where it is below 0. So from -2 to 6. Notice those are also in brackets. Don't forget with brackets, brackets mean the or equal to part. So since I can be or equal to 0, I can be right at -2 where it is equal to 0, and I can be right at 6 where it is also equal to 0. All right. Again, sorry for the long video, just trying to help you guys out. As always, please let me know what questions I can do to help you guys out as well. Bring it on. I'm waiting for them. All right, talk to y'all soon. Bye.